Semiconductors, also known as microchips, are one of the most crucial technological innovations in the last few decades. Regarded as the foundation for digitalization, the so-called digital gold shines today as a key enabler of artificial intelligence. From cell phones and supercomputers to luxury cars, data centers, and even fighter planes, these commoditized goods are needed by most electronic devices of modern society, and thus they carry great economic importance and even potential geopolitical risks. But what exactly are semiconductors? Well, in a nutshell, they can be defined as electronic circuits on a small flat piece of silicon wafer. But a more fancy definition is that they are solids with an electrical conductivity between that of a metal and an insulator. Conductivity is caused by electrons, holes, or polarons, also referred to as carriers of charge, which are set free by ionization. Ionization may be produced thermally by particle collision, light, or a magnetic field. These electronic properties can be controlled by external means, making semiconductors an ideal material to develop specialized hardware. With definitions behind, let's move on and talk about their role in artificial intelligence. Microchips contain billions of transistors, which are so tiny they need to be measured in nanometers. Transistors act as electrical switches that can turn a current on and off. The ability to control electrical currents allows the processing of data or signals, such as binary inputs, common to computer systems and software, which are the foundation that enables artificial intelligence. This takes us to our next question. How powerful are microchips today? Processing power can be measured with various metrics in relation to semiconductor performance. Nevertheless, we can get a good idea of it by analyzing transistor count over time and by utilizing Moore's law. Gordon Moore, past CEO of Intel, predicted in 1965 that the density of transistors in a chip would double every 2 years. Take a look at this graph showing the progress in silicon technology. We can see an exponential growth in the number of transistors that we are able to place in a 1 mm square area. In 1970, that number was about 200. Today, that number is around 100 million. In fact, since 1956, computing power has increased 1 trillion-fold thanks to the advances in silicon technology. Now that's a lot of power. Processing power comes very handy since new technologies such as deep learning and AI utilize models and algorithms with intensive mathematical computations. This requires high-performance processors to aggregate, analyze, and interpret massive amounts of data to learn from it and make decisions. The ability of making automated decisions in a practical, scalable way is what could unlock the vast potential of AI in areas such as healthcare, efficient energy storage, and automated manufacturing, to name a few, which requires massive amounts of processing power and data storage. Because of this, it is estimated that by 2025, the world will be producing 1 billion terabytes of data, and according to the World Semiconductor Trade Statistics, the global semiconductor market is expected to reach $515 billion by 2023, followed by $576 billion in 2024, with most of the demand coming from Asia. Today, chips have become so crucial that they are now considered a matter of national security. In 2022, the US banned exports of high computing power chips to China and passed the Chips and Science Act into law, which, according to the White House, provides $52.7 billion for American semiconductor research, development, manufacturing, and workforce development. This represents an extraordinary effort that intends to reduce the dependency in other countries, such as Taiwan, which now produces most of the world's advanced chips and has recently been under pressure. Now, politics aside, there is no doubt that semiconductors have produced countless technological breakthroughs, and considering the improvement in energy efficiency, processing power, and the rise of artificial intelligence, we can only imagine what future innovations in computing can bring to fruition. And that's it for today. What do you think? Please leave a comment below, and remember to subscribe and like the video if you found this informative. Until next time.